This is the question asked in today's skillrack daily challenge. So we are given two strings S1 and S2 as input. The string S2 is the rotated version of S1. So if we rotate the string S1 in any of the directions, either left or right, then at a particular point we will reach this string S2. And our task in this question is to find the direction in which with minimum rotations we can reach the string S2. So let us see how we are getting the value L2 for the sample input 1. So this is our sample input 1. Now let us find all left rotations of the string S1. So these are all the possible left rotations of the string hello. Initially with 0 rotations the string remains as such. In the first left rotation, the first character of the string H is taken and moved to the last, and the remaining characters are as such. So the first character alone moves to the last. So the H comes to the last and the remaining characters remain as such. So this is one left rotation. Now if we perform another left rotation on this string, then it becomes two left rotations of the string hello. So now if we do a left rotation for this, then we should move this E to the last. So this E is moved to the last and the remaining LLOH are printed as such. So this is two left rotations of the string hello. Now our target string is S2. So the string is LLOHE, and with two left rotations of the string hello we have reached LLOHE. So in left with two rotations we can reach LLOHE. Now let us find all possible right rotations of the string hello. These are all the possible right rotations of the string hello. To do a right rotation, we will move the last character to the first. So the last character of the string hello is O, and this O is moved to the first, and the remaining characters are as such HELL. So this is how we perform right rotations. So when we perform right rotations for the string hello, we reach the string LLOHE in the third rotation. So this is the first rotation. So this is the 0th rotation, and this is the first rotation, second and third. So when we perform right rotations for the string hello, in the third rotation we reach LLOHE. But when we perform left rotation for the string hello, we reach LLOHE at the second rotation itself. So this is minimum. So that is why in our output we print L2. So the L denotes left rotation and the number of rotations were 2. So L2 is our output. Similarly, for our sample input 2, when we perform 3 right rotations for S1, we obtain the string S2. So we are printing R3. So the R denotes right rotation and the number of rotations is 3. And here in our sample input 3, when we perform left rotation for the string S1 for 4 times and we perform the right rotation for the string S1 for 4 times, we obtain the string S2. So we print A4. So the A means any. So if we perform any left or right rotation, at 4 rotations we can reach the string S2. So now let us see how to write a C program for this. So let us start from our main function. First I am creating two character arrays named S1 and S2, each of size 101 characters, and in the next line I am accepting the string S1 and S2 as input, and then I am creating a for loop that iterates from 0 till string length of S1. So here the reason we are iterating till string length of S1 is, suppose if we perform left rotations for the string hello, then the total number of characters in the string hello is 5. So at most we will be able to do only 5 rotations. So that is why I am iterating from 0 till string length of S1. And in every iteration of this loop, we will be calling this function rotate left and right. And we are passing the string S1, S2 and the value of I in arguments. So let us see how this function is working. So in this function, initially I am creating two character arrays named left rotated and right rotated, in which we will be storing the left rotated string values and right rotated string values of S1. And in the next two lines I am copying the string S1 into left rotated and right rotated. So the value now stored in the string left rotated and right rotated will be s1. And then I'm creating another integer variable named L, in which I'm storing the string length of s1 in it. And now we have to perform the left and right rotations. So first I'm creating a loop that iterates for n times. The value of n is nothing but the number of rotations we have to perform. So this part of the program does the left and right rotation for one time. The same if we want to perform for n times, then we should do this again and again. So that is why I am creating a loop that iterates for n times. So we will rotate the string left and right for n times. And here we are performing the left and right rotations simultaneously. So first let us see how the left rotation is performed. So to do a left rotation, we have to take the first character and move it to the last, and all the remaining characters must be moved one position before. So first I am creating a new character named left, and I am storing the first character that is present in the string left rotated. Now we have to move all the remaining characters one position before. So I am creating a loop that iterates from 0 to L minus 1. The value of L is the string length of S. So we are iterating only till L minus 1. So in every iteration we are storing the character that is present next to it at the jth index. So all the characters will be moved one position before. So after the execution of this for loop, the last character of this string left rotated would be empty, and we have to move the first character to the last. So the first character we have already stored it in this new character named left. So in the last position of the string left rotated, we are going to store the character left. So now our character would be left rotated once. And now if we want to perform the right rotation, we should perform all the opposite which we did for the left rotation. So first we will be storing the last character in a new character named right, and instead of moving all the characters one position before in this loop, we will be moving all the characters to the next position in this loop. And instead of storing in the last character, we will be storing in the first character. So when we perform this operation for n times, we would have the left rotated and right rotated. Now we have to compare the string left rotated and right rotated with s2. So after the execution of this loops, we are going to check whether the left rotated and the string s2 are equal. So if left rotated and s2 are equal, and also the right rotated and s2 are equal, then we are going to return 0. Or else if left rotated and s2 are alone equal, then we will be returning -1. Or else if right rotated and s2 are alone equal, we would return 1. Or else we would return -2 if nothing are equal. So now let us go back to our main function. Here in this loop, we are storing the value that is returned by the function in a new integer variable named flag. And if the value of flag is equal to -2, then it means that both the left rotation and the right rotation of the string is not equal to s2. So whenever the value of flag is not equal to 2, then it means that either a left or right rotation or both left and right rotation is equal to s2. If the value of flag is equal to 0, then it means that the left rotation and the right rotation were equal to s2. So in those cases, we should print a and the rotation number. So the rotation number would be the integer I. So I am printing a %d, and for %d I will be replaced. And if the left rotated is alone equal to s2, then we returned -1, and if the right rotated is alone equal to s2, we returned 1. So we are including those cases also here. Now let us check our program with sample test cases. So now I have given the sample input 1 and our expected output is L2. So we also get L2. And now I have given the sample input 2 and our expected output is R3. So we also get R3. And for the sample input 3, our expected output is A4. So we are also getting A4. So this is the logic behind today's daily challenge. Thank you for watching.